Last Friday, a startup founder was reportedly using a coding agent in a popular hosting provider and live posting about their experience when it accidentally deleted their production database. Now, I want to have a conversation with people who, like myself, build these agents. Let's take a beat and think about this. How many people will it be acceptable for this to happen to? 10? 100? 1,000? Is this the future we want to build? We've done some great stuff. It feels good. We're making headlines, but if we stay on the path we're on, they will be the wrong kind of headlines. I don't want to single out this particular tool vendor. We've seen similar snafus with different products being used in various ways. I believe right now the entire space is vulnerable to some form of this. And I'll explain what I mean, because we need to make things better. You probably know that the strength of large language models is producing lots and lots of plausible output fast. Therefore, their usefulness is bound to the quality of the guardrails we're able to put around that. That's part of what agents try to provide. In this case, there were certain requirements, it seems, around needing the user's permission to run a command. And it seems to have been embedded in the LLM prompt, at least according to the customer's telling. That would be strange if true, because the real guardrail needs to be handled on the tool side or the agent code. Prompts are not the place to put a constraint that needs to be guaranteed completely. Everything in the prompts is a suggestion, effectively. We can also see the convenience trade-off at work, since the platform made it very easy to use the agent and directly make changes out there in the world. We need to be cautious with things like that, but I'm not here to critique their architecture. I think this ties back to a problem in our entire product space, because people are pushing towards the convenience side for a reason. We end up wanting to give agents too much autonomy because the alternative is really frustrating. It's manual approvals, human bottlenecks, checking over all the copious output, increasingly more output that's coming out of these coding agents. And now a person must look at it, try to understand it, test, develop some sort of justified belief that it belongs in your code base or not. Or do you really want to run this command at your terminal? Do you really want to download the script? Call this tool, whatever it's trying to do. The risk profile must be navigated constantly. We are forcing users onto this perpetual slider between frustrating and catastrophic. We can feel like we did our part if we don't give them those catastrophic capabilities ourselves, but ultimately we're just inviting them to slip and let it happen. And then we've pushed the risk onto decisions we can say they've made. But here's the question. Are we setting them up for success? It's true that we have these emerging tools with raw capabilities that are just too compelling to ignore. Benchmarks show this, and user experiences show it on a daily basis. But a benchmark that tells you you can complete a task 90% of the time doesn't tell the story about what happens when it fails. Because if that failure is catastrophic, it cancels out the value of the other 90% that was successful, or at best, it will greatly dampen how compelling it is because of that energy spent weeding out the disasters. A better path would be for us to understand something about what makes a software development process intrinsically safer, and make sure our agents are operating that way out of the box. We're not starting completely from zero trying to figure that out. Of course, we have a lot of history experimenting with different software development practices intended to reduce risk. We've needed to do that because humans are also somewhat unreliable, famously. I don't mean to imply that AI models have exactly the same strengths and weaknesses as people. They are very different kinds of entities. But yes, some of what we've learned about building a safe process in the past can be applied here. Some practices I've seen very effective include test-driven development. Many suggest that we should be teaching agents to follow that. I think it's a decent idea. It would bring them up to speed on some of the best techniques available back in 1999. It'd be a good start. Today, I would like to suggest something more futuristic, something more audacious. There's this famous quote from Dijkstra that Testing can guarantee the presence of bugs, but never their absence. Many people quote it out of context, thinking that it's just meant to say something like bugs are inevitable. But in fact, he's arguing that they're not, that in addition to testing, we should use math, and that is how we can show the absence of bugs when we really need to. Formal methods is an umbrella term for the pursuit of applying mathematical rigor to software engineering. It comes in a number of forms. For instance, formal specification is the practice of turning your design docs into a precise model you can validate. Formal verification involves doing proofs on code itself. We can verify these proofs with certainty, not by trusting some fuzzy AI model, but by using bulletproof algorithms in software like the Lean Proof Assistant. Consider Fermat's last theorem. It was unsolved for over 350 years until Andrew Wiles finally proved it in 1995. His proof took 200 pages and relied on results from all across mathematics. Checking it took years of international effort. Gaps were found and patched along the way. I mean, talk about having a code review bottleneck. But here is the magic thing. When it's formalized in Lean, the problem statement looks like this. Think of that like a spec. Now, you could paste a proof below that. It could be 100 lines or 1,000,000. I don't care if it's written by you or an LLM or your pet cat for all I care. I don't even need to read it. If Lean validates it, we know that it's correct. Perhaps in the future, you could see the greatest mathematicians using something like Claude or ChatGPT to formalize their ideas and then checking them with the Lean prover. But actually, that's the present, because we already have the greatest living mathematicians like Fields medalist Terrance Tao doing just that. This does work for math, and it works for pure computer science. But will it work for practical software engineering? There are some hard limits. It's true, as you may know from the halting problem, analysis of arbitrary code can't be solved in the general case. But that's fine. We don't need that. On any given day, what we need is to understand specific properties about some specific code. That's often possible. When we avoid arbitrary code and instead accept some constraints on how we code, we can enable this reasoning much more. Now, there are also soft limits. Program proofs can seem possible, yet hopelessly difficult. That is a legitimate concern. Despite major advances over the last 20 years, I'd be lying if I said it was easy. It's not easy. It's hard. It's not ergonomic. It's poorly supported by our existing tool chain. If you're out there attempting these techniques, you are a trailblazer. Either a high-risk industry niche or your own personal values have driven you to climb a mountain. Now, the people have climbed it before, and they beat a pathway, they left some supplies, or whatever mountain climbers do. I don't really get out much, but the point is we've seen the top of the mountain. We know what's possible. And over the next decade, we're putting in a ski lift. There is already more progress out there than you might know. We have verified code live today, powering parts of your web browsers, your operating systems, thanks to Project Everest by Microsoft and Carnegie Mellon. It's in our cloud providers like Amazon and Google Cloud. And as these big players make investment in the verification infrastructure based mostly on their own safety-critical needs, the groundwork makes it cost feasible for more and more applications to follow in their footsteps. Someday, it could become as commonplace as unit testing and linters. So in this adoption curve, when do we get on board? Are we ready to join these math coding trailblazers? That's the choice we'll have as the builders of coding agents. I think it's inevitable, not if, but when. Ask yourself, do we aspire to be essential infrastructure? Will we have an obligation to reason very carefully about the behavior of these systems? Do coding agents represent such an opportunity that carefully controlling the risk becomes mandatory? If you're asking me, absolutely yes. Billions of dollars are being invested based on the expected impact of agents in software development. They will become essential infrastructure, meaning their reliability must become not only tolerable, it must be exceptional. But I actually don't need to appeal to some feeling of obligation because it just makes good sense. It's a clear fit for the domain. Think back to the basic challenges with LLM and agent output. Recall that it's most useful when output would be expensive to produce otherwise, but is relatively cheap to check. That's been the rule of thumb. That is why our users report so much more success using AI for new prototypes than on legacy code. Working on bigger and older code bases, validating the consequences of a change becomes harder and harder. As a result, the value proposition of coding agents on legacy code, while still compelling, it becomes filled with all these caveats and review bottlenecks. Formally verified code has quite a different profile, though. It's notoriously difficult to create, yet very cheap, almost free to validate, to verify its correctness, at least relative to the specs. To give you a rough idea of what I mean, suppose you need to create 1,000 lines of code, and someone told you that you could spend 10 times as long and be almost certain that it's bug-free. Depending on the situation, it might not be worth it to you. You might not have 10 times as many hours to spend on the task. But if you're using coding agents, it's a different question entirely. You probably don't care if the agent spends a few more tokens or takes a few more minutes. You do care if you can trust what it throws back at you. If I'm able to understand a few lines of spec and be more confident in hundreds of lines of code changes, it completely shifts the economics. So that's my pitch. We should create formally verified coding agents. It's kind of a vague challenge. What precisely am I asking you to prove? It'll take many forms. It takes some literacy in formal methods to even understand what questions make sense to ask. It could mean writing a coding agent in a proof-aware language, or one that produces verified code, or one where we've specified some key component of the system, like the permissions model. Maybe the assumptions and planning the agent does along the way could be externalized into a prover. There's any number of ways this could work. Let's experiment. Even if you start with just one verified component, one guarantee in a sea of probability, you are moving us toward a safer future, a future with less guessing and more knowing. Whatever the approach, let's build tools we can trust. Right here.